There are default and static methods. They're only about creating new objects of the type of the function interface. Okay, I'll give some examples here. Okay. Okay, so the various interfaces which we have got, or the various function interfaces in this package, for all of them, fine. So we are talking about those interfaces. Okay, so let me start with the consumer, right? So if you say consumer of some type T, okay, so I have a consumer, right? So this consumer has a default method, okay, right, which returns a consumer of the same type. The method is returning a consumer. It says and then parameter is a consumer of the type T. So you have this thing to be done after this. Okay. Say for example, see what is a consumer? It is something which takes input, takes some action on it. It's not going to return a value, right? So for example, we have written a consumer which takes input as account. Okay, so there is a consumer taking input as account. I'll just write the kind of action it would do. The action it does is it sends an SMS, okay, to whosoever this account is. Fine. So idea would be account dot. Okay, in our case we haven't kept many fields in the account, but for this account, who is the owner of this account? What is his mobile number? And I need to send an SMS. Use the SMS API and send the SMS. Because there is a withdrawal which has taken place, right? Maybe some kind of a notification you want to send. So you send this, right? So this will be one particular consumer of account, right? Consumer of account SMS sender equal to this. Okay, so there is one consumer which is a SMS sender. Okay, there's another consumer which is a email sender. And sends an email. To the account holder, right? Okay, so what you could do is, okay, I can say I now have a consumer of account, right? Okay, notify sender. Okay, notify account. Let me just equal to, I'll say SMS sender dot and then email sender. So this notify account is doing both the things. So from one kind of a function, lambda expressions are representing functions. I have a function which takes care of sending email. Another function takes care of sending SMS. So this one will first do this and then it will do this. It's going to be sequentially done, okay? It's not going to be in parallel anyway. Okay, so you could, maybe there are multiple things, multiple consumers you might have created individual simple consumers, right? Only simple consumers. And then you would like to create a new consumer which is picking up some of them, and you can create one of them, or one from all of them. Whatever way you would like to come by. Okay, the user has opted that he would not like to have notification on email. Okay, fine, then just use the SMS sender. But he wants to, so there are various options and he has ticked some of them. So based on that, yes, you can create a new consumer from that. Okay, according to the choice which he has made. Choices basically. And you got consumers for each of the choice. Then consumer can be created by saying, okay, this and then this and then this and then this. So multiple things could have been done. Okay, and then, so do this, it's taking action. So I want to create a new action which is a combination of, but always remember it's going to be in a sequence. Okay, so this is one thing we have. Okay, now similar thing can become applicable to a function. Let's think of a function. You have a function from t to r, right? Okay, so this is what is a function. Okay, so in this function we have a default method, and which says, yes, you will get back a function from t to u. Okay, where it says and then, and parameter is a function which is from r to u. Okay, see, it's something like this. Okay, you got a function here. If it's a function, takes one input, type is t, return type is r. Okay, this is one function I am having. Fine. I am having another function which can take r as input and return a new thing called u. Okay, so it says fine, if you got two such functions, you can combine them so that you now have a function which is taking u, taking t and returning u. So that's the whole thing, is one function. So from two functions, you can say, okay, do this, the output of this to be used as input to the next function. So that becomes a new function for me. And then this is your function 1, f1, let's say. This is f1 and then f2. And so f3 equals f1 and then f2. Okay, yeah, now you're talking about exception handling here, right? So failure can happen anywhere. So if it's a unchecked exception, that's fine. But one thing, if you note, all of these methods which we have discussed in the java.util.function package, none of them has a throws. So it's only about unchecked exception. And this is only about defining functions, understand? We are not invoking those methods when we are writing lambdas. We are only defining new functions and making them available. To invoke the method, that method called on an object of a function type, you will have to call a method. Then the method execution starts. Fine. See, when we were writing the for each, right, and we said, okay, I'm passing a consumer as a parameter. You have created a consumer as a parameter, right? But the for each method has taken it as a parameter, then within the for each it has called the invoke the method on the consumer which you have passed. It has then invoked the accept method of the consumer. That's when what you have written, that code starts. Okay, just creating a consumer. Fine. So this is about creation part. Okay, this is about creating functions. All of this is only about creating functions from existing function. Okay, fine. The errors would come when someone is using it. Okay, fine. So I can create a consumer, and that's not going to create any problems. Fine. Provided the syntax is correct, it matches my return type being void. Now I'm not returning a value. Fine, I have written such a thing, such a lambda expression, or maybe as a method reference. It's fine. Okay, fine. But when someone invokes it, yes, if there's a unchecked exception, yes. When you write a consumer or any of these implementations, when the code which you're writing, you cannot be using a checked something which is throwing a checked exception. Okay, I'll give a simple example. For example, someone says, oh, I just want to open a file for input. If you call this, I'm only going to open the file for input, right? So action is, yes, a string is given as a parameter, so it's a string consumer. Okay, so let's say, okay, so someone wants to have a string consumer. Okay, so and I'm just taking another example. So we have a consumer of string. Okay, what is it? It's a file opener. Okay, just as an fine, no one would do this, but just as an example. So equal to, give me a file name. Okay, and for that file name, I'm just going to call the construct of file input stream, and that file name becomes my, okay, let me make it shorter. Okay, f name is my parameter here. Okay, fine. This could also have been written as, how do we write this? Consumer of string file opener equal to, yeah, what can it be written as? Colon colon. Okay, right. So this doesn't have any errors, that's one thing. Okay, but no, this has a compilation error. This would be a compilation error. Oh, we felt there won't be any error, but there's an error. Because this lambda expression is not a consumer. No, it's not returning. This one is not returning. Acha, oh, because I've said new. Okay, new means it would create. Okay, so I'll do something like this. You want to have a, so this would go as a supplier, but okay, let's have a consumer of, okay, let me think of a different one. So I have a consumer of file input stream. Okay, we haven't seen what it is, but it has a method called read. It has a method called read. Okay, so equals, yeah, some file input stream. Okay, fine. So it's consuming a file input stream, and it is just saying fis.read. Read would return a value, something which returns void. Okay, if it's returning a value, let me just make it as a function. To int function, because it's returning a int. It's a to int function because yes, this read method returns int. Okay, but this would not compile. It matches the method signature, but one important thing what is done here is the method read has a throws for IO exception, which is a checked exception. You won't be able to use anything which has a checked exception. To do that, you will still want to go ahead with this. You want to do this, then you will have to go for a lambda expression only. You don't have a chance of using a. See, I would have written it as a file input stream or it is file input stream : read, right? There is nothing but file input stream : read. No, that cannot be done because this one, if I have to write like this, I'll have to say the code has to be written with this. Okay. You'll have to put a try catch. You can't be having a throwing of an exception here. Try this, have a catch, and maybe whatever it is. Okay, fine. This is the only way you could have managed it to be using a. So there is a try catch, and of course there's the end of that. Right? Yeah. Okay, so this is correct, but this one no. Clear? It has a. We don't have throws in any of the methods, and you cannot override a exception. Fine. You can't be having a throws in an overriding method. You cannot introduce a new throws there. Okay, so such methods which have a checked exception, throws for a checked exception, if you are using them, no, they will not be allowed to be used in your standard functional interfaces, java.util.function package. None of the methods which we have discussed yesterday, okay, those 43 of them, all those abstract methods have no kind of a throws there. So keep this in mind. Yeah. I should mention this. These are not valid as a consumer, right? Okay, but they are valid as a function. Function from takes input string, returns a file input stream. Okay. Okay, but this is also not valid because this has a throws IO exception. Okay, file not found exception. Okay, so this is not valid. Okay, fine, I'll remove this. And so no question of using method reference in such a case. You'll have to have this in a try catch. You will need a try catch. If you still want to go ahead, yes, you can, but you will need a try catch. So it's only through lambda and no method reference in such a case. Okay, fine. Okay, so let's proceed with some more methods like this method in the default, some more default methods and static methods as well. So function of tr, right? If we are looking at this, this was one method. Okay, so what was that method doing? On a fine, so you have got, you create one function from an existing function. This function takes t as input, returns r. So I should have another function which can be applied after this. Okay, so you want to create a new function by combining two functions. There's another way you might like to combine with another. So you got one function. So it's like, okay, let's say we have type t1, t2, and t3. Okay, there are three types, t1, t2, and t3. Okay, you got a function from t1 to t2. Okay, that's our f1 equals, and let's not worry how it has been created. Okay, you got another function which is from t2 to t3. Okay, that's our f2. Okay, then what we have seen is you can create a function which is from t1 to t3. Okay, which is f3 equals f1 dot then and then f2. Okay, that's what it is. Fine, and then, but we have another one which says, oh, I want to on this function f1. So let's have another one f0. Maybe I'll say function is f okay, which is from the output is t3 to t4. Okay, this is f0. Okay, you can write like this. You can say, fine, I have from okay, if I want to use f1 itself, 1 to 2, so which is giving me t1. Yeah, t3 to t1 is my function, right? t3 to t4. Let's create one more time. t4 to t1 is my function. Okay, so you can create a function. Okay, so I'm first using the function, then you'll know the method name, which is from t4 to t2. Okay, where we'll so this is f4 equals f1 dot compose f0. The method name is compose. What is compose doing? This is to be applied before. What is passed as parameter is the one which has to be applied before. So whatever is the output generated from that function goes as input to the function f1. Compose is saying, okay, this comes before. And just copy. Yeah. Okay. So like we have this method. There's another method called default method to which returns from. Okay. Return type will be R. Input is going to be not T. It's going to be okay, let me say V. Okay, let's say from V to R, instead of saying and, then the method is compose. The parameter required in compose is saying your return type is going to be T and you have V as input. Okay, yeah, and this is called before. Fine. So if that function which is from V to T, fine, and that is given on the method which is from T to R. Okay, your function is from T to R, and so this has to generate t, which goes as input to the function on which you are invoking the default method. Okay, so you can do and then that looks much easier to understand, but even compose is also available, right? So you'll say, okay, this function, but before that this function, so output from that given function, which is my parameter. Okay, so you are so the example which I have shown is saying on f1 only, find both methods on f1, but the type of function is from t4 to t2. Right? So f1 is generating the output, right? This is the return type, which is consumed by f1. f0 is generating that output because f0 will be invoked first. Okay, so this is for creating new function objects basically, right? Default methods. As far as the function, so let me repeat it here, t comma r is concerned, there is also a static method, okay, which returns a function, okay, which is t comma t, a function from t to t. That's a method called identity. A static method to return a function from t to t. That's a method called identity. So this is the identity function. What does it do? This is equivalent of writing a lambda expression. This is fine. The equivalent lambda expression goes below. Okay, the lambda expression is nothing but x is my input and I'm returning x. A function, whatever input is given, returns the same value, is known as the identity function. Okay, so these are through a static method. So just a function dot identity. You don't have to write a lambda. Lambda involves arrow, right? That doesn't look good. Okay, so mainly, okay, even the method reference, it looks better because there's no arrow and those kind of syntax. Okay, fine. So a static method like this, okay, so even if there we even have the by function, for example, from the by function is from, if it's t comma u comma r, that's a by function, right? We understand that. Okay, so if there is a by function, how do I compose? How do I say after and then? Sorry, and then. We even have a method called and then here, but that one returns a function. So we have this as a default method. Yeah. So on a by, from a by function, you may be creating a function. Function which is from t to r. Okay. It takes two inputs, returns one, and then we are applying another one on that. So R2. Yeah, it's a by function. What is returned is a by function. Sorry. U comma, let me say RR. Okay, fine. So this method returns double R. Okay. Name of the method is and then. Parameter is a function which is from R to RR. Okay. This is what is done after. So whatever is the current by function takes two inputs, returns one value. Okay. So we are applying one more function after that, adding some more functionality to the output generated by function, so that it now is a by function giving the new output. Okay. Right. So it's all about combining functions basically, combining various kinds of functions. So static method like this. Similarly with predicate, yeah, predicate of some type T. What's the method you will expect? And, or, negate. Okay, so static methods of those kind. Fine. We can have a look at the API itself, right? Okay, let's go to the API. Fine. Quick look, but okay, so we have this. So yesterday we had this entire list in a different order the way we wanted. Okay, let's look at the buy consumer, for example, right? Look at the methods here, and oh, you have the method called and then even here also. Two inputs doesn't have to return a value. Fine. So take two inputs, use this consumer. Fine. Okay, so do this, also do this. Also, the same two inputs, give it to another consumer. So I'm combining two buy consumers. Okay, fine. Yeah, this is the second one, right? So there is a default method here. Okay, it's a buy consumer of TU only. I'm taking T and U as parameter. But so do this. Once it is done, use the same two inputs on another buy consumer. Okay, so it's a new buy consumer because two inputs are used. Fine, one function, one buy consumer was existing. Fine, so two buy consumers were existing. I'm creating a third one. Okay. Fine. See, I think buy function we have seen that. Whatever is in buy function, because binary operator is also a similar thing, right?
In the previous example,
yeah,
the buy function
is
not returning anything, right? Because it should not return.
Buy consumer, yeah.
Yeah, it should not return a value.
Yeah, not returning.
It is just performing the functions.
Yes.
Okay. Yeah. It's not giving any value out.
No, no. Okay, I'll show it like this here. Maybe. And it's so if you look at it, it's like this. We have two buy consumers, right? And we are creating a third one. Okay, how do we do that? So this is one buy consumer. Okay, two inputs, right? And this won't do anything, right? I have one more buy consumer. Okay, this also takes two inputs, right? So now what I have done is I have taken a buy consumer which combines both of them. Says, okay, whatever input I give to you, right, use it with this one first, and then the same two inputs, use them here. But first you have to finish it there. After, it says after that, sequentially, one by one. Fine. Okay, so that way they can combine. Okay, so methods are here. From existing function types, you are creating another function of, I mean, the type is same. It's if it's a buy consumer, you're only talking about creating a new buy consumer. Right? Okay. And so, okay, now binary operator would have an interesting static method here. Recollect the math class has a method called min and max. Math class. Static method. Min, what does it do? Fine. Two integers gives you the minimum. Two integers gives you the maximum. Right? It was in math or it was in integer class. I'm not sure. But anyway, so same way, give me a comparator. Now it's about reference type. So we have to use comparator. So give me the comparator and I'll give you a function which takes two binary operator means two inputs, return object of the same type. So I'll make comparison and return whatever is the minimum of them. So that's a min by. So there is a static method. So these are static methods of the binary operator. You need to give it a comparator. Just give a comparator of that type. And so according to this comparison logic, yeah, I'm a function, so which will always give you the maximum of the two. Fine, this function is going to take as parameter two inputs. Right? Binary operator, two input returns one output. The output will be whatever the maximum of the two according to the comparator. Okay, so min by, max by. Fine. Okay. So like this, yes, we can have. So you can have a look at all those. Fine. So consumer is fine. I've mentioned about the consumer. We can have a look at the predicate, I think. Yeah. So same thing. So most of them, yes, they will be having something similar to that. And let me take you to the predicate first. Yeah, here's the predicate. Okay, the methods here. Fine. So you have the method, default methods. Let's just only look at first the default method. So default method is AND, negate, and OR. Okay. Fine. They return Boolean. So I have one predicate which returns Boolean. Okay. I have another predicate which will also, so both of them will be given the same input. Fine. But then I have to AND the two Boolean values returned by them. So that's giving me a new function. AND. Fine. So for a given predicate, right? So AND with another predicate. Okay. Test1 and test2. Test1 or test2, pass both of them. Okay. Test1 dot negate. Negate means when true false is changed and it would be reversed basically. Okay. Look at the static method now. Okay. What is this static method? Is equal, not again creating a negative predicate. Give me a predicate, I'll create a new predicate for you. Okay. And this one is equal. What is this is equal? Fine. I'm creating, so I have a ready-made predicate which is about testing equality with a particular object. Okay. For example, someone might say, I would like to check about equality, equals method, right? For a string maybe. Same thing. Okay. So I can just create, because it's about creating a predicate. So predicate means, okay, let me use it here. Okay, I'll show an example where we can be using it. Maybe we have a collection of string, right? We have a collection of string, okay? And then cs dot remove if, what do we pass? A predicate as a parameter. You would have written a lambda expression, right? Instead of that, you may write predicate dot is equal or equals, yeah, let's just check that quickly, is equal, right? And here I'll just say if I find this, remove it. If there is an empty string, okay, fine. Otherwise, yes, what would have been the lambda? And we would have said given a string s dot equals, yeah, when the two are equivalent, right? A lambda, instead of writing a lambda, right, that arrow thing, okay, just invoking a method, right? Predicate dot is equal, and I want a test for comparing with equality. Fine. See, these the remove if method is using it, but if someone had just created the object, then it wouldn't have been executing it, right? It's not about executing that equality. Okay. Fine. It's then being used by the remove if method. Fine. Remove if is calling the test method on that predicate. Okay, clear?